pressure looks good.
Doubling up. Roger, roll with Linux.
Water towers can fly! Yes!
Tango Delta nominal.
Flighting down for SC off. Bring in SC off.
Yikes. You bet. Concur. We don't need any more of these.
All right, folks, you know the drill. Let me know after the rousing intro music there if you can hear and see us. We have a very special guest today. I'm John Galloway with NASASpaceflight. Give me some 5x5s in chat to make sure that all the little lights are blinking in the proper order so we can do another exciting episode of NSF Live, our weekly talk show, whatever, podcast with visual aids. I don't know what we're going to call it today. But anyways, it looks like we've got tons of 5x5s in chat over here, so all the lights are blinking correctly. And let's hop right in and tell you about the show today. It's a special guest show, and we have Mr. Tim Ellis of Relativity, who will be joining us, he's already here. He's like, honestly, right here, here talking to us today. Tim, thank you so much for joining us today.
Yeah, of course, John and Thomas, super excited to be here.
All right, and y'all have seen the nerd over on the very side over there, Mr. Thomas Burghardt, news director for NASASpaceflight. Thomas, how you doing?
Oh, I'm doing great, and thanks for coming on, Tim. Looking forward to talking with you today.
Absolutely.
Yeah,
so that's how it goes, y'all. We're going to be talking all about Tim's awesome rockets here. We're going to be talking about relativity. It's an interactive show. We're going to be asking questions. I mean, we have questions that we're going to ask, but we're also going to be reading chat. If you have questions for us, tag us in chat at NASASpaceflight. They go into software. Y'all know the drill. You know how it all works if you've seen the show before. We will be trying to keep our questions topical. So if we're talking about something and you have a question about it, put that in. If you ask, like, why is the sky blue? Maybe I'm not going to ask that question. We'll see. Depends on how many good questions we have. But we will be reading those. Please understand, we can't ever get to all the questions. We do try. Some of your questions I may roll into a little ball and ask them all at once. But just please be understanding. We do try to get as many questions as we can. Also, super chats. We keep the show going because of y'all's support. But when we have a special guest, we make the majority of our time me doing the intro about... No, I'm just kidding. We want the majority of our time to be Tim Ellis talking here. So if you do a super chat or something like that, we absolutely appreciate the support. We're not going to spend a lot of time talking about those today. But Thomas and Tim, y'all want to take it away? Let's hear about Relativity Space and learn what's going on in the world of 3D printing rockets.
Yeah, we'll jump right in, and of course, we're going to chat questions are going to start coming in, but we're going to start with some of the obvious things, and probably the first and foremost thing to talk about is what's going on right behind Tim there, actually, because Terran 1 is out at Space Launch Complex 16 in Florida, getting ready for its first ever flight. So what's the latest progress on that front, and what kind of things are the teams working toward getting ready for that first launch?
Yeah, of course, Thomas. So I'm here in Cape Canaveral, was here at the end of last week, going to be here through the beginning of this week, and we have some pretty exciting testing coming up. So we've got, as you mentioned, we have our stage 1 on the launch mount right now. We're doing and working up to a full mission duty cycle test of our first stage on the ground before we do our first flight. So we've already done what's called a spin start test. So that's where you just test the ignition systems and the very, very beginning of ignition of our 9 engines. The photo you see behind me, though, is getting past that first test. So we've also done a 6-second duration test, which got the engines up to full power. And then we're working to do a 20-second test next, and then a full mission duty cycle test after that, which will be several minutes. So full flight duration, that's what's coming up on the first stage. And then what's also very exciting is we've already done a full flight duration test of the second stage. So that was at NASA's Stennis Space Center, where we built up our own engine and vehicle test stands. And then the second stage we tested several months ago, and then it's now sitting in the horizontal hangar for final integration with the first stage once that testing is done. So it's been a really exciting couple of months here for Relativity, and we're still just a few weeks away from first launch and being ready for first launch with these final testing steps.
And so is that second stage already completed all of the testing it'll do like on its own, and it's just waiting to get integrated with stage 1 to go beyond what it's already accomplished?
Yeah, exactly. So stage 2, literally the next time that engine lights should be towards the edge of space after getting through stage 1
Awesome.
burnout, essentially. So yeah, that's very, very exciting. Of course, the team's super pumped about that.
That's awesome. And so once stage one gets through, like you said, a 20-second test and then full mission duty cycle, once that's done, is that the final test before you bring stage one horizontal and go into integration with stage two?
Yep, that's right. So essentially, once we do the full mission duty cycle test for stage one, we'll go back horizontal. We actually have a different launch mount on the launch pad right now that was specifically designed to allow us to do a full duration mission duty cycle test. So to our knowledge, no other company has ever actually done a full flight duration test on the actual launch mount or launch pad at Cape Canaveral. So we're the first company that's doing a full flight duration stage one test. Usually you just do a full second, a few seconds. It's kind of more of a checkout test.
Yeah.
So when we do stack both stages together, though, we are going to also then do another checkout test, which that one should be very quick and really not take that long, because at the time the first stage has already done a full mission duty cycle test. Really, you're just looking for different modal frequencies or other things that may look a little bit different than when you don't have the stage two on top, but you also at that point don't really need to go retest a lot or add a lot of risk, frankly, at that point.
Yeah. What is it that enables that? The ability to do a full duration test on the actual stand? Is there something special about the stand? Is it the amount of thrust? Like, why can you do that?
Yeah, so it wasn't what we had originally designed, frankly. I think the very first plan when I started the company is we were thinking we could build a first stage test stand out at Stennis Space Center. But this was a good example of creativity from our engineering team, where we really thought, building a single engine test stand, which we now have 4 of them operational at Stennis Space Center. We already had to build one for a single engine. And so we actually originally designed that stand to do both single engines and second stages together. So they have the same capability across both of them. When you're obviously going from single engine to 9 engines, all of a sudden that stand looks more like a miniature launch pad than it does like a second stage stand. And so at that point, once we realized there was synergy between them, the biggest thing that we had to do is add a lot more water than you normally would at the launch pad. So we, of course, have a flame diverter like many other launch companies. It's actively water cooled, but then we have a lot more water capability, because not only do we now have water for the rainbirds and the flame diverter and Fire-X systems and other systems that need water to support a launch, we now have sufficient quantity to run a multi-minute long test, which is, of course, quite a lot. So it is an interesting site to walk down, by the way. You have these, of course, really big liquid natural gas and methane tanks, liquid oxygen, and then really huge water tanks compared to what you would normally see.
What you normally think. Gotcha. Cool.
Yeah.
And you mentioned that special launch mount that the rocket's currently sitting on, and that's going to be removed after the mission duty cycle, and you'll use like the standard mount for actual launch operations. Is that how I understand that?
Yes, exactly. So we are using hydraulics to have the stage separation system kind of retract. So it's essentially a 2-part process in simple terms. So you have pins and clevises that first unlatch, and then you have 4 arms that swing out of the way. And so that whole system we're building up right now, right next to the launch pad, just in another hangar, and then we'll swap that very quickly. It looks almost identical. The biggest difference is, and the biggest added complexity is all the hydraulics that you have to have in order to have accurately timed release of the rocket. So, a lot of that timing has to be within, milliseconds in certain cases to make sure you release the rocket cleanly.
Right.
And then even though we have a pretty rigorous test approach, I think as I go through a lot of Relativity's progress, people will probably quickly see that we actually have a pretty rigorous test approach, certainly compared to some other startup launch companies that we've seen. And so that doesn't ever guarantee success, but I do think it helps, especially because Terran 1's not just 3D printed, it's also one of the first LOX methane rockets to ever fly, and it's actually quite big. So even standing next to it on the launch pad, and I just saw the Atlas 5 launch.
Yeah.
Well, I didn't see it. I'll get to that in a second, because I'm actually holding on seeing my first rocket launch for Relativity's launch. I made that promise to myself 7
Really?
years ago. Yeah, 7 years ago when I started the company, I said, if I'm going to see a rocket launch, it's going to be Relativity. So for whatever reason at that point, I had seen, tons and tons of engine tests, but I was pretty young. I was 25 when I started Relativity. I had launched a lot of my own rockets, and Mojave is part of USC's Rocket Lab, but I hadn't actually seen an orbital class launch before for whatever reason. So I thought at that point, well, I might as well. I was working at Blue Origin as well. So they were doing suborbital stuff. So I thought, well, I might as well. It would be a pretty cool story and good motivation to say I'm only going to see an orbital launch once it's actually my company. So that's a true story.
Like, time out. Were you at the Cape when the Atlas launched?
Yeah,
like you were in the area.
I looked away.
You looked away.
Yeah.
Did you seriously?
Nope,
not watching.
100%. 100%.
Wow.
I did that with Atlas. I did it with Falcon. That was the same day, double header. And then there was, there's been, Falcon's launching a ton of stuff now. I think Atlas had another launch when I was out there recently. So, I've maybe it's kind of a weird tick, but
it's dedication.
I think it's been 7 years.
Takes a lot of restraint to do that. I think.
Yeah, it does. Because trust me, rocket engine tests, of which I've seen many, including at Relativity. Those are near spiritual experiences.
Yeah.
So, and I was a propulsion engineer by background. So, certainly that's the addictive part of doing rockets for me, is once you see the testing, and especially in real life, because video never captures it. I think everyone expects audio to never exactly capture it, but video is not even close either. It looks more like looking into the heart of a star than it does like anything else. So it's pretty cool.
Yeah. For a second there, I was worried, like, I'm going to have to be careful what I show you. Like, hang on, this is okay to see, right? Okay, this one's cool.
I don't think any of our assets are orbital launches yet, so we're good.
We're not trust me, I've watched a million videos. It's it's actually pretty, it's pretty cool, even being at the company offsite, like a leadership team.
That one's
offsite.
Cool. Like,
No, those are all good. They're all good. Yeah, we were watching the first Dragon mission actually with astronauts in it at a company offsite, and I have a video I took on my cell phone. It was pretty special for me, and honestly quite an honor, because I was standing at the back of the room and took a video, and our team was of course watching it on a TV, and in that frame was a guy, David Giger, who was the first employee on the Dragon program and ended up leading it for 8 years. Tom Mueller, who of course we're now working with at Impulse, we'll get to. Tim Buzza was there. He was the first VP of launch at SpaceX. Zach Dunn went from an intern to leading stage 1 propulsion for Falcon 1, and then ultimately leading all of production and launch for the whole company at SpaceX, and was there a really long time. So it's just very cool to frankly be very humbled and honored. We've got these people now working on the Relativity team, and they literally were the ones that helped make this happen. And I was standing there watching this mission live with them. It was pretty special.
It's very
cool. That is so awesome. And honestly impressive that you haven't seen an orbital launch, given how much time you spent out here, especially recently. But
I look away every time.
Well, hopefully Terran 1, when it launches, you'll then be free to launch all of the orbital launches you want while you're out here.
And trust me, I can't wait.
Of course. And you mentioned, so another topic to talk about, one of the first Methalox rockets that's going to fly. So methane and liquid oxygen fueled. That's a common trend, I think, among a lot of next generation rockets. Relativity is not the only one, but I think Terran 1 is definitely in the running to be the first. What is the reasoning behind that choice of fuel for Terran 1 and, of course, Terran R down the line as well?
Yeah, of course. So we have done liquid oxygen, liquid methane, and I use methane and natural gas kind of interchangeably. I think there's a technicality that it's liquid natural gas, depends on the methane percent concentration. I think there's some technical differences obviously between them and percents methane and what other hydrocarbons you got in there. But I think for all practical purposes, unless you're really into the details of the true rocket engineering, they're quite analogous. But yeah, so we use both. We've used it since the beginning because really Terran 1 has been a development platform for a much larger, fully reusable rocket. Almost from when I started the company. I don't want to veer off your question too much, but just another story to tell. So we started about 7 years ago in Y Combinator. So after the kind of now famous, I guess, cold emailing Mark Cuban. We also got into a startup accelerator called Y Combinator almost right off the bat. And so during YC, that's really when it was still just me and our co-founder, Jordan Noon. We had basically just started the company, a month before, and we had to figure out what we were doing. So initially we were going to do a 150 kilogram payload launch vehicle. This was back when Rocket Lab had just started doing Electron. There was really not, this kind of quote unquote 100 other small launch companies that have been in development. Like it still seemed like a pretty novel thing that someone that wasn't a billionaire, 100 millionaire could start a rocket company and get venture capital funding. So that was the size we started in. But then we walked into our first office hours where we're supposed to get advice from the partners at YC. And we told them we were going to scrap that plan and do a Falcon 9 size reusable rocket straight out of the gate, because that's really what we thought was the right level of ambition.
Yeah.
And he essentially told us we were truly crazy and guaranteed to fail if we did that. And so we needed to make sure that we went after something that was a little more reasonable. He also told us we shouldn't do 3D printing in rockets put together. This guy Sam Altman, he since is a fan, and every time he told me I can tell this story, I just gotta say he's a fan now, not a doubter, because he definitely is, and we're good friends. But the whole point from the beginning, like I just use those stories to illustrate, we really have wanted to do a big rocket for a long time. I think, so Terran 1 using liquid oxygen, liquid methane was clear that was necessary for reusability. We also got experience with what's called autogenous pressurization. So this is we've later found a much more difficult to execute method of pressurizing tanks. So you essentially gasified some of the liquid oxygen and some of the liquid methane from each respective propellant tank. So the methane, you essentially use the regen channels of the engine, because you're already flowing 100% of the methane through the regen channels in order to cool the main combustion chamber. Yep. And so the way our engine works, you're at a pressure high enough that it's super critical. So it essentially has a fairly smooth transition from a fully liquid cryogenic state to kind of technically not a gas, but pretty close to a gas in properties. And then you dump that back in the chamber. So you already have a pretty good heat exchanger in the main chamber to do that. But then for the oxygen, it's a little harder, because in our case, since we don't have a pre-burner, since it's a gas generator cycle engine, you want to dump the liquid oxygen, or you have to put part of it through a heat exchanger. And so that has been one of the bigger things, is both getting the propellant temperature right for the methane system and getting enough heat into the ox system, such that the temperature coming out of it and going back into the tanks is high enough. Because the higher the temperature, the lower the density, of course. And so you really want to have as lightweight residual pressurant as possible. That's why helium is usually such a good pressurant. And even helium, usually people will heat up before it goes into the tanks, because you really want to minimize residual mass as much as possible. And so while autogenous helps because you don't need carbon overwrapped pressure vessels stuck in a liquid oxygen tank, which of course I guess has semi-famously caused some issues in the industry. It is a very effective system as far as the performance goes. And so, autogenous versus helium, these are the kind of trade-offs, by the way, on a rocket architecture that are probably some of the hardest to make. It's the secondary systems that are a little bit more insidious as far as, what's the right thing to do.
Gotcha. And thank you, by the way, autogenous. We always argue, is it autogenous? Is it autogenous? And he just said autogenous like 15 times, so we're going with that. Like somebody clip that. In the future, we'll just play your audio every time we need to say that word.
Autogenous. Pretty sure. We're not the first to do it, though. I think the Space Shuttle did it, at least on some of their tanks. So, people have done it before.
Okay. Autogenous. Good deal.
There you go. So I want to circle back. At the very beginning of that answer, you mentioned something that I definitely wanted to ask about, so I'm glad you brought it up. So you mentioned Terran 1 is a development platform for Terran R, which of course Terran R, to my knowledge, is only the second ever proposed fully reusable launch vehicle in the world. And so, or at least the one that's currently in development still. And so Would you expect Terran 1 to take up a role similar to, say, Falcon 1, for example, where it's going to fly the first couple missions, it's going to give you all of that experience in building an orbital rocket, but it's not planned to be keep being flown down the line, and Terran R is the real launch vehicle, so to speak?
Yeah, I think it'll be a little different than the Falcon 1. I think the biggest difference is, frankly, there is actually a huge market for that payload size, and Terran 1 is quite a bit larger than Falcon 1 ever was. So Terran 1's baseline payload is 1,250 kilogram payload to LEO, or 900 kilograms payload to a sun synchronous orbit. So that's pretty significant. We of course have worked with companies like Iridium, Telesat, DIU, NASA for payloads that we see being customers of Terran 1. We've signed contracts with all of those companies for launches on Terran 1, but we also have signed way more contracts than that on Terran R. I think that's part of part of it is we've sold $1.2 billion worth of commercial contracts on Terran R over the last 3 months. And we have not finished all of the contracts that are currently in work for that vehicle. So we just see the amount of commercial demand and need for there to be a second quickly moving company similar to SpaceX in the medium to heavy lift launch market, which does not exist. Especially, I think it's a terrible conflict that's happened at the beginning of this year, but I think the Russian-Ukraine war further exacerbates what we see as a huge supply shortage in the medium to heavy lift launch market. Soyuz, by our back of the napkin math, was about 20% of the world's commercial launch capacity, and that just went entirely offline. And then, of course, SpaceX is pretty dominant at this point, so they have most of the rest. So when you look at sans SpaceX and sans Soyuz, what launch capacity there is, now that Amazon Kuiper just bought all of the
bought everything else.
They just did. They bought everything else.
Yeah.
Of course, there's all sorts of stuff we know under NDAs, and I won't be able to comment on all the details. But the high level picture, when we look at the math, is there's something like a 2-to-1 to up to 3-to-1 supply and demand deficit for medium to heavy lift launch vehicles, even assuming all of the ramp plans that other large launch companies have for their plans. So essentially, even if you take Rocket Lab Neutron at face value, whatever they published in their kind of public, SPAC prospectus, or I don't know what it is now, but take that at face value. Say they're going to do that. Astra's going to do everything they're doing. Blue Origin's doing everything they're doing. Arianespace is doing everything. MHI, Mitsubishi. You just keep adding it all up, and it's actually still not enough, and it's pretty definitively not enough.
That's interesting, because there's been a lot of conversation about, and this is specific to the small sat launch market, where Terran 1 kind of starts, where there's all these different rockets, and there's a lot of different opinions about how many is too many. Some executives think that 0 of those companies will even survive. But Terran 1 is in a different payload class. If you look at Astra, Rocket Lab, Launcher 1, stuff like that, they're all much smaller than Terran 1, even though you might still class it as a small sat launch vehicle. So you're saying that since it's in that slightly bigger payload class, it's not going to be replaced by Terran R. Both rockets will have their place?
Yeah. Oh, yeah. So to directly answer your question, the answer is no, we're not officially canceling Terran 1. We're just going to prioritize more Terran R stuff initially, and we're going to put a single AON-R engine on Terran 1 as a block upgrade. So that's the game plan, is that we're going to replace the 9 engines on Terran 1's aft section with a single AON-R. That's a 250,000 pound thrust engine that we're in development for right now. I'd love to talk about it. But once we replace those 9 engines, which by the way, I think even as of 3 or 4 years ago, that was always the game plan with Terran 1. We just never talked about it publicly, but we've been talking with investors and such about this for a really long time, because even with additive manufacturing, reducing the part counts significantly and the production cost significantly, no question, consolidating 9 engines into 1 engine, especially if it's an expendable vehicle, which Terran 1 is always planned to be expendable. Reusability makes very little sense at that payload size. We could do it. Like, we did look at what our payload would be if we did it. It's just harder to close the business case for use at that that payload size. Reusability becomes more about ramping production rate than it does about cost at that point. But this was always the game plan for Terran 1. And so we will go and we are talking to customers about selling more Terran 1s for this block upgrade in the future.
And as you mentioned earlier, you kind of alluded to the fact that you're expecting to fly Terran R much more often than Terran 1, which I'm sure comes into the reusability conversation as well, right? If you're only going to fly X number of times a year, reusability becomes less and less worth it until you have a much higher flight rate.
Yeah, exactly. Like basically when we looked at the total addressable market, it was, Terran 1 certainly was large, but Terran R was about 20 times larger. So it's about 20 to 1 total addressable market for the bigger vehicle versus the small on an annual basis.
Right.
Gotcha.
Gosh.
And that block upgrade, so consolidating stage 1 down to 1 engine, totally understand that. Would I be correct to assume that the upper stage will stay the same? Because if you take the Aeon R vacuum version from Terran R and put that on Terran 1 somehow, that sounds like that would be a very interesting thrust to weight profile there. So I'm assuming the original Aeon vacuum staying on that upgrade?
Yes, exactly. Yeah, the Aeon 1 vac was a pretty solid engine, and there's actually, that's an engine. I've talked a little bit about this before. I think we'll also have use once we get to a fully reusable second stage. I think it'll be great to have that as a product in our tool belt.
All right, cool. I have tons of questions to keep going, but we haven't gone to a lot of viewer questions. So, Dus, do you want to take a couple of those before we keep going?
Yeah, so I don't know if anybody saw me sort of incredulously looking at this monitor up here, but this is the highest ratio of detailed technical questions to random stuff that we've ever had on one of these shows. Like every question, I'm like, that's a good question. That's a good question. It was just adding them all to the queue over here. So if y'all saw me making faces, that's what I was like, really? These are great questions. I'm going to start with this one because we've been talking about Terran 1 versus Terran R in the size differential. And so let's put on screen, that is the difference between sort of the Terran 1 size and the Terran R size, right? And you were just talking about, you said like a 20 to 1, what term you use, like market size or ratio or something?
Yeah, market size, basically. Yeah.
But you're not talking about the size of the rockets there. You're talking about the business that the rockets can support, right?
Right. Yeah. Business the rockets can support, but even on a payload capability, and actually we haven't released a new Terran R update in a while. It does look a little bit different than this now. It's actually slightly larger. I think this one was 16-foot diameter. It's now 18. This one had 7 engines on the first stage. It's now a 250,000 pound thrust engine, and we have more of them on the first stage. So things have changed a little bit, but it's
email it to me right quick, and I'll put it on the screen.
Yeah, we'll have a bigger.
We'll stand by.
That's about all I'll have on updates for that now. But yeah, so Terran 1 is like I mentioned, 1,250 kilogram payload. Terran R in reusable mode is 20,000 kilograms payload. If Terran R were fully expendable, kind of apples to apples with Terran 1, it would be over 35,000 kilograms payload. So Terran R essentially, I don't remember the numbers offhand, but it's in the Vulcan kind of class, maybe sans some of the solid boosters on the side, depending on the configuration. So it is squarely in the medium to heavy lift market. Gotcha. Of course, we really do think the 20,000 kilogram payload reusable configuration is the one that is going to cover almost all of what the market needs. Certainly, we have talked with OneWeb and had a contract with them, and some of the other low Earth orbit constellation providers. The 20,000 kilogram seemed like the right place at this point in time. But I think more important than picking the right configuration in the long run has actually just been the rate that we can evolve the product definition. So we are currently changing the diameter of Terran R quite a bit, and we just print 6 inches bigger, 6 inches smaller. We did that with Terran 1. We can change dome profiles. We can change stiffening structures and patterns and what that looks like. So there's a bunch of things that we can do on Terran R to make it go to where the market is going and what is most needed at the time. certainly that's not going to be just a press print and it's done process. There's a lot of testing and development and qualification. So there's a lot that has to go into it, but that's one of the reasons why we've built such a big team around the platform that we're developing. Because I do see Relativity as a rocket company. I get asked this all the time too. Are we rockets or 3D printing?
Right.
I think we're the first application layer 3D printing company where we're building our own end products, more similar to Tesla, where they're not a roadster company or a Model S company or Model X or Y.
Right.
They are a car company. They've got multiple products, but underneath it all, they're building the Gigafactory with their own batteries and electric motors that they're leveraging across all of the products that they're building. So we're building a 3D printing factory in the world's largest aerospace factory built around 3D printing, which to me is just a software-driven automation technology that removes fixed tooling and lets you iterate the product definition very quickly. And we're building that new capability and then just going to market with these different rockets, as a starting spot. Don't get me wrong, I'm like such a passionate rocket nerd at this point in my life. And, it wasn't so long ago I was designing rocket engine turbopumps and combustion devices and such myself at Blue Origin. So, I think rockets are absolutely near and dear to my heart, even just from a passion and mission focus as well.
Yeah, I think a lot of people have sort of run into that where it's like it's one thing to design a rocket or design rocket systems, and it's another thing to actually produce them and fly them and then do that at scale so that it supports the market and then that sort of stuff. Like those are not necessarily the same thing, designing it versus actually deploying it and putting it out there. So
yeah.
I like it. There are so many good questions here. I'm going to try to speed run some of them here. Let's see. There's so many. Do we know what the first payload of Terran 1 is going to be?
Yeah, we do. We do know what the first payload is. Unfortunately,
can you tell us?
Unfortunately, not ready to talk about it yet. I can tell you that it's going to be meaningful. It's fun. We haven't even told our internal team yet. We'll probably do it all at once, internal, external, just given our scale at this point. It's gonna be super fun. I'm excited about it.
All right. Okay, good deal.
We know it's called Good Luck, Have Fun, which I think is a very cool name and very apt with the Terran rocket naming as well. So that's all. I love that.
Yeah, I will say for first launch, we to my knowledge, we would be the first venture-backed rocket company in history to succeed on launch 1. So I think I'm very well aware of that. I think that's probably the right framing for the first mission, is that we'd be the first one to succeed on launch 1. And then doing that with a LOX methane rocket, which no one has ever done before, plus a 3D printed rocket, which no one has ever done before. There's a lot of firsts. And there are a lot of firsts.
So does that build into also like in your expectations for Flight 1? Are you thinking, listen, this would be unprecedented if it worked on the first attempt? Are you prepared for the possibility of Flight 2 is the one that gets there, just like other launch companies?
Yep, of course. I mean, I think it'd be crazy to say otherwise. So we're building the Mission 2 rocket right now. We're also starting to build parts for the Mission 3 rocket. And then the baseline is the NASA Venture Class Launch Services 2 contract payload will be the payload for the second launch, which is the baseline for now. So NASA is the first customer. It'll just be for the second launch.
All right. I'm going to try to get through so many of these questions. A quick one from Musical Wolves. How long does it take to produce each stage? Is it just down to this is this size, this is that size, so it's just a printer time? Or are there other things that sort of build into the complexity of the stage that makes something take longer than you would think?
Yeah, complicated question, depends on the time frame. So certainly for a first version, which we had a lot of engineers building and developing while building the first one, the total print on time was around 6 months for the first one. It's going to be just operationally, it's actually the same print parameters for the second one. It's about 30% faster operationally for the second one, but that's on our third generation Stargate printing technology. technology. So essentially, since we build our own printers, but we don't sell them, that means we can iterate and evolve the printing tech very quickly. So we actually started with, we haven't really publicly talked about it, but we started with a V0 printer, I guess, that was true prototype that we called Gateway. So that was the Gateway printer for the Stargate to come next. And then Stargate, we had V1, V2, and V3. So the V2 and V3 versions were the first production-ready versions that were building flight hardware. So we still are using the V2 hardware, even though it's about half the size as the V3 printer. So V2 is mostly focused on things like the second stage, the nose kind of payload fairing. And then the V3 is focused more on first stage and really tall stuff. But then V4 is a little over, we've printed up to 10 times faster, I think actually 12 times faster, and anywhere from 5x to 12x faster print rate. So we'll be able to take that 6 months and shrink it considerably because of the productivity of the printers. Now we're mostly using those printers for Terran R at this point in time. But I think it's probably one of the biggest questions I get asked, and maybe one of the bigger misconceptions isn't printing the tanks like really slow and really expensive and you could just use sheet metal. But I honestly think when you look at it from a first principles perspective and how fast we're depositing metal and how quickly we've been able to demonstrate printing these structures and changing the wall thickness kind of dynamically across the structural height, as well as adding in different stiffening structures and things that would be extraordinarily challenging and slow to manufacture traditionally. All of that is just in inventing this technology over the last 7 years. So most of that headcount that we've had at Relativity was joining kind of COVID and after. We were about 100 people and now 850 or so people today. Over the last few years. So most of the area under the curve of development has come quite quickly. So we're really in the early days of what printing is capable of. And it's certainly indicative of this almost 10x faster leap forward in technology, which is a really big physics breakthrough. And the way we're printing that is fundamentally different from all the printers that we've done before. Those kind of breakthroughs, I think we're still going to have a lot of them, and they're going to have a very meaningful impact in what additive is capable of doing, whereas traditional manufacturing has frankly been optimized over the last 100+ years. And I look at what Starship's doing. I think, by the way, for the record, I'm a huge fan of them. I'm a huge fan of SpaceX. I'm sure we'll talk about it when we get to the Impulse Mars mission. Really, they were the inspiration for why I started the company. Was no one else had decided to go after the Mars mission, and 13 years of success. And I was like very depressed about that. So I thought there needs to be a second company, and hopefully dozens to hundreds. So we should be that one. And 3D printing tech's obviously going to be needed. So, this was why I started it. So yeah, lots of different things I just wanted to hit on. We can touch on them in other questions, but as far as the speed goes, that's where we're at today. It's about 6 months print time going down significantly, and then we're really in the early days for how good it's going to get.
Tim's alluding to every question that I've already got planned. We're going to deep dive into all of that for sure.
Let's do it.
Yep. So another quick question here, and this one hopefully is something you can answer. What's the difference? You're developing your own printers. You're sort of iterating through that process. You're perfecting things or doing things that normal printers don't support. What's the difference between your printers and just a commercial off-the-shelf printer that you could go buy if you needed to print these sorts of materials?
Yeah. Well, I think the biggest difference is scale. So if you look at the commercial off-the-shelf printers, the biggest thing they can build, when we started Relativity, it was about a cubic foot. I think today, 7 years later, it's about 2 cubic feet, maybe 3, slightly bigger diameter, but not that much. So really the scale is quite small. If you're going to print an entire rocket, Terran 1 being about 110 feet tall, 7.5 foot diameter, Terran R being over 220 feet tall, 18 feet diameter, you have to build the world's largest metal 3D printer. This was the foundational thesis of the company. And frankly, when we started, I think we had a bit of a chip on our shoulders. We thought we were rocket engine developers that knew how to build rockets and rocket engines. Of course, you've got to recruit a big team around that. But I thought certainly if you could build a rocket, you could build the world's largest metal 3D printer. Here we are with nearly 200 people just developing the printing tech.
Yeah.
It is incredibly hard, and it has been far harder than I ever expected. We had to invent our new material alloys for the printer. We're on several generations of that material system. It's designed together with the physics for the print deposition process, which we've iterated. I mean, we've probably iterated the print physics deposition 36 times or so. So it has been a huge amount of trial and error and using the same kind of first principles engineering approach that we do on rockets to the printing systems. And so we use a lot of off-the-shelf hardware, so you can see a robot arm, 6-axis industrial robot arm, power supplies. It's an aluminum wire that is fed in, so essentially weld wire. I mean, at its heart, printing is a welding process,
right?
And so you have full melting between layer by layer, but actually controlling the deposition process, the grain structure for the metallurgy, the solidification, the accuracy, the features that you need to print to get good enough quality to make a rocket fuselage lightweight and survive. That has all been what the work has gone into.
Gotcha.
So it's great because a lot of that work is software and data driven, and once you solve the problem, it's quite an automated process. So then doing it the second time and the third time, it really compounds upon itself.
Right. And I got one more, and then I'll toss it back to you because I know you have an entire huge list of questions. This is something that I sort of think about.
Yeah.
Like if I've got something 3D printed, I can hold it in my hand and be like, yep, that's 3D printed, because like the texture of it and sort of the way that it's put together, it seems, rough, bumpy, I don't know. And I know that there's all sorts of different technologies, but how does that affect the outside of a rocket? Do you have to go sand it down? Like, what are you doing there? Because the 3D printed things I see, I wouldn't think would make a very good part of a rocket. You know what I mean?
Yeah. No, of course. So we had the same question when we got started. So especially with our own printing tech. So initially we have an internal term, what we call parasitic mass. So this is essentially what is the mass penalty of our empty structure versus what an equivalent sheet metal structure would look like. This is just for the straight wall sections, by the way. So we actually save mass when we don't have joints and bolts and other secondary structures that have to be attached to it. We're not including that. So just looking at the pure kind of very basic straight wall. We initially started with in the realm of 25 to 20% parasitic mass. We've now gotten that down to about 5%. And so we're essentially paying a 5% dry mass fraction penalty on just the straight wall sections. Then we also get some of that back through the stiffening structures that we add.
Right.
And then also stronger material alloys that we have in development for Terran R. And so all of that, I think, is going to start to make printed structures better than they would be made traditionally. When you can start to integrate parts together and don't have as many joints, I think it is certainly possible, and we see it in the next couple of years where the structures are actually better than they could possibly be made traditionally. But then for someone else to do it, you would have to figure out all of these different steps, and it would be quite challenging.
Right.
And so right now, the extra they're kind of ridges or surface roughness. I think it looks a lot worse by eye than it actually is. We actually 3D scan and measure and track all of that as we're printing.
Right.
Some of it actually adds strength in the rocket itself. It isn't extra mass. It actually does contribute to the kind of pressure load carrying capability of the rocket. And then aerodynamically, most of a rocket spends its time flying in the vacuum of space.
Right.
So the actual time spent in the atmosphere is quite low. And then you also start going supersonic quite quickly, in which case then there's kind of shock waves and other stuff that help the drag from the extra roughness not matter as much.
The air helps keep the air off you, like literally the shock wave sort of with a wavefront. So
yeah, exactly. We did sand a whole structure once just to show we could do it. We just didn't really think the benefits were that worth it. It was extra time. It was lighter, but just increasing the engine thrust by a little bit actually solved the extra mass that we have today.
Okay.
But again, I don't think it's ever been about printing definitively kind of kicking every other technologies, but today I think it's more about the rate of compounding progress and just how much faster this new tech approach is going to be, and also being necessary if we're ever going to have 1 million people living on Mars. Someone has to be the company that's going to develop what this factory looks like.
Yep. Good deal. And I'm going to say real quick, chat, I asked one question and then Tim answered like 5 of your questions that were in the queue with his answer. So just because I didn't say your answer out loud doesn't mean that you didn't get your answer. Tim, you literally answered like 3 of the other follow-up questions on that one just because you're so
awesome.
Thorough. Like you know your stuff. Oh, honestly, Thomas.
That's good. Well, honestly, I appreciate having an hour and a half to go a lot deeper, and also with what I'm assuming is a little bit more of a technical audience. So I think it's I think it's great to be able to dive in deeper than I normally would.
Absolutely. Thomas, speaking of diving in deeper, your turn.
Yeah, for sure. So we were 3D printing. Let's keep talking 3D printing. You mentioned that people ask you all the time, and I was asked to ask this question on the show, but we've already addressed it. Is Relativity a rocket company or a 3D printing company? And you said rocket company. The 3D printing tech, as I understand it, is a big part of Relativity's overarching goal of Mars. You want humans to be multiplanetary, much like that other company that we talked about earlier. And that 3D printing tech, though, goes hand in hand with that goal. How do you see that tech maybe being applied on the Red Planet?
Yeah, of course. So I think first answer. So yeah, that was definitely why I was inspired by. I was watching SpaceX land rockets, and I think I left Blue Origin right after the first New Shepard successfully landed, and then SpaceX successfully did it, I think a month after that. So it was right around that time. And I was just quite sad that no one else had started a company to go after making Mars happen. I think it's a super inspiring mission. I think if we were having this conversation and 1 million people were living on another planet, it would fundamentally redefine what it means to be a human being. For me, it's way less about an asteroid potentially destroying Earth. Frankly, I think in 100 or 200 years, we're far more likely to destroy ourselves than an asteroid impacting Earth. So I think for me, it's more about expanding the possibilities of human experience and emotions and art and society and culture, because we've been living and dying, generation after generation on Earth for thousands of years. And to me, it's about, well, what is that all for? And we live in a time where we have the real ability to be the generation that does make that happen and makes humanity multiplanetary, which to me is just the coolest adventure. So that's the reasons I want to do it. I remember starting Relativity, wrote that on the back of a Starbucks receipt, and it has not changed since we started. So that has always been at the core. But I think to answer your question, we're a rocket company because we're building rockets, but I do think in the long run, we're going to be the world's first end product 3D printing company, where we're building many end products with 3D printing. So I've framed it to the team internally. I sort of see a 4-step strategy. So the first was Terran 1, which is getting a rocket to orbit, showing we can be one of the handful of companies that can launch a rocket successfully to orbit. That still, even if we weren't 3D printing, is a monumental challenge. And so we want to prove that. Terran R is then being able to serve what we see as the bulk of the commercial launch market with a fully reusable rocket. So I think that is clearly important, that there has to be another medium to heavy lift, fully reusable rocket in development. I don't think there can just be an ecosystem where there's only one. I'm a again, big fan of Starship. I actually think it's definitely going to be successful. I think, Falcon certainly has been so successful. I think Starship will too. But I think there has to be another company, especially one that's not building their own satellites. So we're not planning on building our own satellites really right now or into the foreseeable future. So then the third step, well, I'll get to the fourth step is then Mars and building an industrial base on Mars. So the third step is really once we have the 2 rockets flying, and we're very focused on that because we have a lot on our plate right now, and definitely care about focus and making sure that we're executing and not getting ahead of ourselves while still having ambitious plans and like a plan and strategy for what we're going to do in the future. But the third step is once we have a factory that can 3D print a fully reusable rocket the size of Terran R, we've now built what is probably, potentially one of the most disruptive technologies in the aerospace industry in our lifetime. Because once you can print a fully reusable rocket the size of Terran R, all of a sudden things in commercial aviation, other sectors in aviation really have the potential to be disrupted with the same 3D printing factory, and just reconfiguring it via software. If you can build a rocket and rocket engines and avionics and the whole integration of all of that, you do have the recipe for the core ingredients to then take on what is $1 trillion aerospace sector. And so for me, that is our Starlink. Like that is our big kind of program expanding beyond rockets. I think the rocket market itself is growing to be quite huge. Certainly multiples bigger than what it is today by the end of the decade. So rockets alone are going to keep us busy for a while. But if the goal is to put 1 million people on Mars and become, the largest kind of mission focused company that we can, then certainly the rest of aerospace is probably one of the biggest untapped opportunities in Silicon Valley that does not have a company that's really disrupting it at scale yet. So I actually view what Relativity is doing more like the Tesla opportunity, competing against Ford and Mercedes and BMW and all these kind of car companies that have been around for so long, but didn't really have valid competition from a startup that was actually succeeding. And that's where the 3D printing factory and that end product approach to using 3D printing, where we're not selling the printer, and we're not buying, or relying on outsourcing this core capability of large scale printing, but we own it ourselves. Like that is a key part of it, and so that's how I see that question.
Yeah, it's interesting because you're focusing on, we talk about, building the machine that builds the machine. And when you build that machine, that's almost one of your first line things, because that machine can build other things. You can print a rocket. Why can't you print an airplane fuselage? Why can't you print other things with that technology you've designed? As opposed to, we had to build this machine to build the machine, and then we built the machine, and then we flew it into space, and we used that to put some payloads up there, which is how we're going to pay the bills, right? Like it's the other end of the spectrum. That's really interesting.
Yeah, exactly. I mean, I guess it's probably, I'm probably going to revise how I think about it, but yeah, it's sort of the very end state North Star is almost like building a von Neumann probe or something like that, like a self-replicating spacecraft that can build more copies of itself. That is a doomsday scenario, by the way, so we have to be careful. It's also certainly a long way away. I think the other pieces for making Mars happen, so clearly sending people to Mars, that's necessary to make it happen. I have a friend I've known for a bit, a guy named Casey Handmer. He's actually written an open source book on colonizing Mars and what it would take to essentially have a bootstrap society there. He's a mathematician. He's kind of a polymath. It's probably one of the better books that I've seen on the subject about rate limiting steps and what is required to make that happen. And there's certainly parts of it that have a conclusion that essentially human beings on Mars have to be more productive per capita than the most efficient human beings on Earth, in order to prepare for the next wave of people coming on ships, because they're going to be coming on the kind of 6 to 9 month intervals. And so if you look at that, I think it's pretty clear that automation and AI and robotics are going to be a key part of making Mars happen. And there really aren't other companies focused on that particular part of it. And so I think for me, 3D printing is just a way initially to build probably things like spare parts and just increase the robustness of missions, because you won't really be able to send a whole lathe and mill and forgery and factory and all the different tooling that you would possibly need. So I think 3D printers are more mass efficient initially. And then I think after spare parts, probably things that are really difficult to launch. So kind of high volume, lightweight objects. So pressure vessels is a pretty obvious one. I think things for food storage, water storage, propellant storage, potentially habitat liners, things like that. But I think at the end of it, what I really thought is it's inevitable somebody has to build the first Mars industrial base company.
Yep.
The path to get there and exactly what that looks like, you can certainly update your assumptions as you learn more information along the way. But Relativity is certainly the one that the only other one now, sadly, in 7 years that said that's our mission, except for now Impulse joining us. So I'm very excited. There's a third company that's part of their mission. And then I have a friend that runs a company called Icon, which is 3D printing habitats. They do have some contracts with NASA on the moon and Mars. They're really cool, actually. Right. I think that technology will be useful. But I think it's really just about building parts of it that no one else is. I still think energy generation, food, I think the odds are very high we're going to have some form of genetic modification, both of food and possibly of human DNA, to sustain more radiation and gravity effects. Like I think actually we underestimate the amount of fundamental technological change that is going to have to happen to make Mars possible, but all of it will be beneficial for helping humans on Earth.
Yeah. That's a recurring
fantastic
theme.
We are going to so quickly run out of time on this episode. There's so much to talk about.
Everybody, the 15 people who asked if 3D printers would be useful on Mars, yes. Okay, next question.
Fantastic, Tim.
Thomas.
All right, I do want to deep dive into Terran R for a bit, and we can start with the Mars mission. So this is the first commercial mission to the Red Planet. It's going to be a Terran R rocket launching a payload from Impulse Space, which, as we mentioned, was founded by Tom Mueller of SpaceX rocket development fame. Tell us a little bit about how that's even going to work. I mean, Terran R is this fully reusable launch vehicle. Obviously, the first stage will be recovered in some standard form, and I'm going to ask you about that in a second. But the upper stage, the upper stage is supposed to do the trans-Mars ejection. So what's that stage going to do after it releases the Impulse payload?
Yeah. So for this flight, which is slated to be the first payload mission on Terran R, the upper stage will probably not be reusable for this particular one for the first launch window. So we do have 3 launch windows: 2024, 2026, and I believe 2029. So one after that. May have been dates quite off a little bit there, but yeah, it's pretty close to that. So we have 3 launch windows with exclusivity with Impulse. So we're certainly going to make this mission happen within those. There's no question about it. And we're gunning for the first one, for that being the first payload on Terran R.
Oh, wow, really? So the first Terran R mission is going to Mars.
Going to Mars.
Yes.
I like
the very first one. Like literally the very first one is going to be an orbital flight from our launch pad at LC-16 to Mars with Impulse. They have to do, I mean, we have to build the Terran R launch vehicle. They have to do most of the work of getting it to Mars. I mean, of course, we're in the business of launching payloads. It's got to be a Mars trajectory for the mission. So
But as far as hardware goes, that's not fundamentally different from any other launch, right?
Same hardware. Same hardware. We actually have a good amount of payload performance margin. We actually could fly that mission reusable and still make it.
Right.
Yeah.
That would be interesting. Okay, so that's another question about Pad 16. We know that's used for both Terran 1 and Terran R. Is that the launch mount will be designed to be able to switch out or like reconfigured between the 2 rockets? Are there going to be 2 launch mounts at the complex? How does that work? Because you said you're going to fly both.
Yeah, that's right. So ideally, I do want to keep the Terran 1 launch pad capability so we could fly both in the future. I think it's going to be interesting to have capability to both deploy constellations of satellites and resupply them with Terran 1.
Okay, yeah.
Okay.
That sure. And does that apply also to Vandenberg? Because you mentioned the Iridium partnership, which came with the announcement of near building B330 out at or building 330. Sorry, Bigelow Aerospace. Crossed my moment there.
Slightly different.
But slightly south of Slick 6 over at Vandenberg, you're gonna have a pad there. Is that gonna be for both rockets as well?
Right now, that one's just for Terran 1. So the QD arcs there are more of something we have to look at for Terran R, but yeah, certainly that one's still just Terran 1 for now.
Okay, gotcha. And then, all right, so let's talk Terran R reusability then, with regards to not just the Mars mission, but future missions overall. By the way, first mission going to Mars, that's like the best debut flight ever. That sounds awesome. But in the broader sense of things, what is the kind of recovery methods for both stages? The start stage 1, I didn't notice any landing legs on the stage 1 render yet. But you mentioned that the render's changed. So what kind of baseline are you looking at? Are you looking at downrange recoveries, return to launch site recoveries?
Yeah, so these are maybe a little lighter on details on, but yeah, right now it's propulsive landing. We're focused on building the engine hardware. We're actually planning on testing engine hardware this year at Steno Space Center. So quite a bit of a full-scale hardware is in development. For landing, it's going to be propulsive. We're planning return to launch site as well as downrange landing. One of the harder things to figure out actually is as your vehicle diameter gets bigger, the return to launch site landing gets harder because of shockwave acoustics. So when the base diameter is bigger, it's a much bigger shockwave. And so you kind of have to net that out if you want to do reusable. So 18, we're kind of at the edge of what we think we can do. But downrange, we'll certainly be able to do that as well. And then for second stage, the baseline's propulsive, but we aren't saying more than that right now.
All right.
Okay.
So we'll just keep an eye out for catch towers if they show up at some point, and we'll
a huge hammock or something like.
Yeah, it's interesting. I think some of that stuff, it's always interesting to come second in an industry because you also have got to see. I mean, I never worked at SpaceX myself, so I'm resigned to just looking at YouTube videos, just like anyone else. And yeah, it is interesting to see some of the solutions people have done. That's one that we'll see if it works out.
Have you waved off any solutions based on the observed experience of other organizations? Like somebody tried something and you're like, okay, that didn't work out so well. Like, were you thinking along the same lines, but you waved off?
Yeah, that's a good question. I think I would say probably parachute recovery of a first stage, actually. I do think Rock Lab's going to do it, by the way. I think it's just, again, it's kind of like, all right, it's going to kind of help you a little bit. And that's probably a decent amount of engineering work.
The Terran rockets.
Different scale. Different scale. I also think maybe just seeing people doing smaller rockets and continuing to stay in smaller, but it's like a little bigger than small, but it's still small. I don't know. I think for me, at least, that's maybe more of a business answer from just market and opportunity set. I am very glad that we decided to do the much bigger rocket and are really putting serious resources. Obviously, we have hired a lot of people and we've raised a lot of capital, and a lot of the reason, well, pretty much most of the reason we've done that is because of Terran R. So if we were just doing Terran 1, we wouldn't have had to do that.
Gotcha. Thomas, keep going.
Yeah. So I want to talk about the test program. You mentioned Terran 1 has had a very rigorous test program so far, and there's still more to come. When you go up towards Terran R and you're going to experience your first recovery attempts for both stages, are you anticipating that's going to be some sort of, you might have to build dedicated test vehicles like VTVL landers or things like that? Or is that something you'll be able to experiment with, kind of similar to how SpaceX did with Falcon 9, where eventually they launched a few rockets and eventually they said, all right, let's try to land it. And if it doesn't work, that's okay, because the upper stage is still fine. Like, which kind of strategy are you think you're going with?
Certainly every launch opportunity to orbit is a landing opportunity for quote unquote free. It comes with the launch, assuming customer success is most top of mind, and then you get paid to do it. So I certainly think launching customer payloads and getting to ramp rate as fast as possible to make sure we're fulfilling all of these contracts that we signed is the most important goal. And then we will land over the ocean. I'm sure that will be the first thing, is that we'll just attempt to relight engines, flip the vehicle around, land over the ocean. We aren't fully talking about yet kind of all the number of burns we're doing or where, and I think it'll look a little different than what you've seen before. That's the game plan there. And I think with Terran R, certainly, even though printing helps make the rocket and engines and everything a lot better, and more quickly, I think printing is especially better when you go larger, because usually the tooling and the fixed kind of factory stuff that you have to do for building a larger vehicle is a lot more painful. So I think the advantage is actually better for bigger rockets. But then the test stands and the launch pad, like those are still quite big for Terran R. So those are some of the things that we're very focused on expanding. We have quite significant expansion at Space Center. We haven't talked about it yet. So it's one of those other fun things that I can tease, but maybe not give all the details on. We really have all the infrastructure for Terran 1 pretty close to finalized. So we've got the 1 million square foot factory in Long Beach, we've got the launch pad at LC-16, and we have the engine and vehicle stage test infrastructure at Space Center. None of that we have to build up from just blank dirt with no regulatory framework or no kind of history or team that's currently based there. It's all just expansions of what we're currently doing or inheriting existing infrastructure, which I think is going to give us a big leg up.
You mentioned Terran R in the downrange recovery, like the larger it gets and the shockwave sort of affecting the RTLS sort of mode. Does that mean marine assets are in your future? Are you looking at landing Terran R out at sea somewhere for downrange?
I don't think I would try to land a rocket in the ocean raw. So
makes sense.
Yeah. I don't know if that's been proposed before, but my guess is it would be a challenge.
I think there was a CEO at one point that claimed there was nothing wrong with a little swim, but I think that was debatable.
It was debatable if there was nothing wrong with a little swim.
Debatable for sure. Let's talk. We'll get one other kind of recovery method question about Terran R. The upper stage, obviously, it's coming back from orbital velocity at some point, so that's going to require some sort of thermal management. And is there any sort of advantages that you can use from 3D printing in order to provide the structures or the mechanics needed to keep that vehicle cool on the way down?
Short answer, yes.
All right, sounds good.
Yes.
We'll leave it at that for now. I can already tell we're going to need a sequel to this interview down the line.
Exactly. There'll be more information released.
Yeah.
So Aeon R, the rocket engine for Terran R, that will also be part of the Terran 1 upgrade. You mentioned testing later this year. Is that still on? And what's the latest on that front as far as engine development goes?
Yeah, for Aeon R.
Yes. Sorry.
Yeah. So we've got gas generator built and finishing production. So we'll plan to have a GG test for the turbopump. The GG, by the way, I think has higher fuel flow rate, or it has a higher flow rate than our main Aeon 1 chamber. So it's a pretty big engine, over 250,000 pound thrust. We're also testing injectors. We've built full-scale injectors, chambers, turbopump, hardware, valves. Lots is starting to get into testing.
All right, and that's all happening down at Stennis. And you mentioned, I like pointing out the difference of, most companies, if they're going to do full mission duty cycle things on their big first stages, they have some dedicated site somewhere else, such as Stennis, for example.
Right.
And you're doing it out at the launch site. But we saw the stage 2 mission duty cycle already take place out there before being shipped out to Florida. Would you expect a similar test kind of campaign for Terran R?
Yeah, I think so. I think I don't think a full flight duration mission duty cycle test on the launch pad for Terran R, I mean, it's over 3 million pounds of thrust,
Right.
is in the cards. That's
Sure.
I think that would be an issue with the range.
Significant
So,
hold down problems there. Like,
yeah, I mean, that's a lot of prop. That's a lot of prop, and it's a lot of thrust for a long period of time. So, that would be ambitious. So we're planning on doing that at Stennis. And then there's some mix of currently we do all the stage 1 and stage 2 interstage, et cetera, structural testing at our facility in Long Beach. So we actually print the sections, we integrate them together, and then we put them on the test stand right away before starting to integrate engines and harnesses and other final components. And so we have a very fast loop between building it and then testing it to the MEOP pressure that it'll see during flight, plus a safety factor on top of that. So all the flight structures, even of the rocket that's currently on the launch pad, have all effectively flown a full flight mission with all the pressure, the buckling loads, the bending loads, et cetera, that would see during launch. And then, of course, every engine has gone through a full flight duration mission duty cycle test. And then we've done, of course, pretty rigorous engine qualification. This is all for Terran 1 stuff.
Right.
My most fun engine test day, we did 4 back-to-back MDCs on the stage 2 engine. So literally the same stage 2 engine. We had to load propellant across multiple test stands that were operating out there to have enough prop to do it. But we literally ran 4 back-to-back mission duty cycle tests, and we're still even running mission duty cycle tests of qual engines as we kind of get the rocket to the launch pad. So we're definitely gunning to be the first one to succeed on launch 1. I think that'd be pretty badass.
Nice.
Das, want to bring in some more viewer questions?
Yeah, absolutely. Do you get any special benefits from 3D printing when it comes to re-entry for your second stage? Can you print a heat shield directly onto the side of it, or does the 3D printed material help you in any way?
I guess probably the same answer as I said before is there's definitely things you can do with printing that you can't do with traditional manufacturing, and that's going to help us with Terran R significantly. It's not even just for reusability, but certainly the 3D printing approach with the materials you can use will help it be more reusable. That's the goal. It's got to be more reusable. Even with 3D printing being very cheap and fast to build, reusability is still a really important part of the business case. It is just that way. That's how the rocket physics work.
Yep. Let's see. And again, it's like, yep, okay, cool. Let's see. Have you looked at, this is a more technical question, have you looked at doing your printing inside of like a tank or submerged or in a non-reactive gas or anything like that? Or are you just printing in regular atmosphere? And is there anything benefits?
There's no... Yeah, for operational reasons, we don't inert the entire chamber.
Right.
That's really important. We definitely have to make sure we're solving the oxidation problem with the aluminum alloys. So we have a way to do that. As far as Mars printed, tangent, but sort of related, we could actually print on Mars essentially in a thermal chamber with almost every parameter other than gravity.
Right.
So you could print with the partial pressure of a Mars atmosphere, with the atmospheric composition, with the right temperature swings that you would see on Mars. So pretty much every facet other than the change in gravity, which really makes it more of a surface tension dominated problem versus gravity plus surface tension and the weld melt pool. And you can simulate that. Yep. So I do think there's a lot we can do on Earth to also show how we can print on Mars, using that approach.
Gotcha. You just said something, you said sort of inerting the entire facility. Does the printing process you're using right now use like a shielding gas, like a welding sort of thing? Does it have something that's flowing over it to solve oxidation problems, or is it just loaded up?
Yeah, I would say essentially, but it's complicated, and I can't talk about all of it.
Okay, essentially, but it's complicated. Gotcha.
Yeah.
Let's see here. So many of these questions, y'all.
I wish it were that simple, by the way. That would have been really easy. That would have been great if we could just do that and solve it. That has been the case on almost everything with the 3D printing.
Yeah.
Is that it would have just been simple if we could, have a robot arm move around in a circle and like there's your fuselage. But as it turns out, we had to create software to simulate the print across a whole bunch of parameters before printing, and then reverse warp the path so that we print a not straight looking thing.
Right.
It actually looks very weird and wavy and not even uniform. It's like super wacky.
Right.
And then it distorts into the right
shape.
Kind of shape. Yeah, while printing. Things like that. There's been a lot of those.
Yeah. Well, if you could just like grab a welder and like zip tie it to a robotic arm, everybody would be 3D printing the rockets. So it doesn't work that way. Let's see if I can grab one more. And a lot of your questions, y'all, if you think that your question didn't get asked, you need to watch this again because Tim has answered so many of your questions just in his answers. Like seriously, I'm skipping some questions because I know you've already answered them. We already talked about smoothing the structure. We talked about porosity problems. Is there any sort of porosity problems when you're doing the 3D printing, bubbles forming and that sort of stuff? Is that another complicated solution?
Yeah, smoothing in the structure, just to touch on that. So we are doing it. We're just doing it algorithmically, and we're doing it with data science. So essentially, because we have tens of thousands of print hours, we're able to learn from all of that. So we are improving the printing. Same with the quality in the pores.
Okay.
So essentially, we have a very accurate map of where all of the pores, flaws, cracks, etc. are.
Right.
We use computer vision to pick a lot of that up, and all sorts of different sensors, as well as the simulation tool we've written. We can actually kind of understand where that's likely to occur. Then we collect data while printing, and then we've done it has to be over tens of thousands of samples of material cut up and scanning electron microscopes and such after the fact. And then there's a big correlation loop between all of that of learning. And so you essentially learn from the data, and it gets smarter over time on its own, together with our team's insights and tagging and et cetera. So there are some pores and cracks. We have a process to go back and repair it if it's too much.
Okay.
But we also have a quality spec that we can automatically detect that we have passed it based on the stress intensity at that particular point in the structure.
Right.
And then we also we use a lot of the same approaches as a normal structure would have, as far as allowable flaw sizes, leak before burst. And we actually, it was great. In order to even launch from LC-16 at Cape Canaveral, we had to have the Space Force buy off on the fracture approach, just like any vehicle would have, and we passed. So I definitely feel good about that.
Good deal. And I'm going to toss this one in really quickly just because we talked about it before the show. But somebody said, when can I get Relativity merch?
We didn't really publicize the launch, but we do have a store live now on the website. So it's got a few items, I think pretty simple and straightforward. Yeah, there you go. Flash it over.
Got some multi-planetary baby pack, it says.
All right. That is, I think that's one of the more popular items of the team.
All right. Won't spend a lot of time on that, but there was a question. There is store.relativityspace.com because a couple people have asked about merch. But Thomas, back to technical questions.
Oh, yeah. So I guess other questions regarding the Terran 1 first flight, because of course, and I think you mentioned this on Twitter, and I love this answer. Someone was asking, what's the progress of Terran R? And you've mentioned that there's already hardware being built, but that the team is rightfully focused on Terran 1 because that's the first flight, and without Terran 1, you can't go on to the bigger rocket. So you mentioned, obviously, the stages are already at Cape Canaveral. Is the payload fairing there? And the payload that you can't talk about, where is that coming from? Is that coming from Long Beach still?
Yeah, I think Payload's still in Long Beach, should be out there pretty soon though. It won't be hard to integrate. And then the nose cone that we're flying for the first mission is out there too. So we have a much larger 3-meter payload fairing for Terran 1. We're flying a much smaller nose cone for the first flight because 3D printing, and we could just do a much smaller thing, and it was easier to do. We didn't need it. Yeah, same with VCLS. Yeah, same with VCLS mission 2. It's also a customized the payload release mechanism for that particular payload. And so it's one of the advantages of printing, because you don't have to just have one design, you can have several. And a lot of that flexibility is driven innovation in the design tools and mission analysis tools, where we can look at different loads and dynamics and such quite quickly. And so I think the flexibility has really evolved into more of a platform where we can also make changes on the vehicle side more rapidly because of the software tools that we've developed.
Nice. I had to play the.
Ask.
Go ahead, Thomas.
I was just going to say, because I've seen multiple renders of Terran 1, and I'm like, wait a minute. Some of those look like a pretty normal payload fairing. Other ones that just looks like you stuck a nose cone on the front of the rocket. So thank you for answering.
That's the answer to that. Yeah.
I had to play the carrier has arrived video real quick. We couldn't get through this show without playing that. So
yeah, it's great.
And so that's the vehicle for for Flight 1. And you mentioned that most of the infrastructure is getting ready, and that should include the launch site. Is there still work to be done at Slick 16 with regards to flight readiness, or is that pretty much ready to go?
It's pretty ready to go. I would say most of the team there, other than that other launch mount that I mentioned, and kind of commissioning the hydraulic system for that, which is probably one of the most mission critical systems on the launch pad side. TE is there, transporter, rector, lots of the data systems. We've commissioned the Rainbirds and a lot of the other water systems, because we wanted those not just for launch, but also kind of as a just in case. I will say, on the just in case point, certainly with methane vehicles, we've also found dual cryo is way harder than with RP1 and LOX, because you have two cryogens, especially a fuel that gasifies. So as you saw with the recent Starship testing, you can pretty easily end up with big clouds of methane outside the rocket, and that stuff will light pretty readily. And so unlike RP1, which kind of just stays a liquid and very concentrated, methane kind of can go everywhere. And so that's just to say, we had to commission some of these other systems a little sooner and been quite prepared. I've been really proud about the team's readiness out at the Cape. They've built up the site in a hurry, but it's a really awesome looking site.
Gotcha.
You mentioned the transporter erector. I think when the first stage was first put on the launch mount, you just were using a normal crane. You actually weren't using the TE. Is that part of the mission duty cycle mount, and you're not using the normal launch mount yet? And that's going to come when you're kind of have the integrated vehicle ready to go?
Yeah, exactly. Yeah, that was there wasn't some grand plan there. That was just, it was practically easier. We had the crane and it was faster, and we could just do that.
Sure.
Yeah, obviously TE is more useful, especially with the second stage umbilicals. You've got to have that, and with the whole launch countdown, being pre-planned and automated quite a bit more. The MDC. The other thing is, there's only a flight computer on the second stage. There's not one on the first stage, because it's an expendable vehicle. For Terran R, that'll look a little bit different in avionics architecture, but we've already planned for that in the Terran 1 avionics architecture, like what you would expect in lots of our choices.
Right.
But the Terran 1 does not have a flight computer on it currently, because the second stage is not attached. So essentially we have to have a dummy Terran 1 stage 1 flight computer, which is using the ground racks to simulate it in order to send it all of the signals for them to test.
Gotcha.
And so when stage separation happens, that's the end of all data from stage 1, and it'll fall on its ballistic trajectory, be expended, and that's the end of that.
Yeah. Sadly, but I'll be happy at that point, because we will have successfully gotten the stage.
Got to separation. Got to separation.
Yeah.
And it will be different for Terran R, of course.
Very.
So another great question here: with all the 3D printing tech, are you using any of your 3D printing tech on stage 0? So the actual ground infrastructure, the launch mounts, that sort of thing, or using more traditional building techniques there for stage 0?
Yeah, it's something we've talked about, especially during COVID, when supply chains for basic things like propellant tanks and such were kind of crazy. But no, we're not. Really, 3D printing does the best when it's a very high value object that does not weigh very much. So really high dollar per pound products. It's one of the reasons rockets are the most economical thing to do currently. And then aerospace products are the next step after that. A lot of the ground tanks are really, really heavy. So it would take a really long time to build. Essentially, the build time is directly proportional to the mass.
Yeah.
It's also the reason why it's going to be so powerful, because each version of the rocket we do, if the goal is to make it cheaper or faster or lighter weight, it's all the exact same thing. All we have to do is optimize the mass. And so the incentive alignment with a printed rocket, I think, is going to be extraordinarily powerful, because we're already better than traditional in certain aspects of it. And we're probably at parity as traditional in a little bit, and there's only very few things that were not as good as traditional even at this point, and we're still just getting started.
Right, makes sense. And it makes sense, like if you want to additively manufacture like your launch mount, you can back up a concrete truck and just add some concrete to it. Like there's no reason to revolutionize dumping concrete on things right now, but that makes perfect sense with the tanks and
we
the mass.
We do have 3D printed parts on the 3D printer, though. I will say that.
You like 3D printed parts on the 3D printer?
Yeah, we do. Nice. Yeah, a few. Yeah.
Okay, as long as you come up with like rules for 3D printers, like a 3D printer must obey the commands of a human. 3D printer can't harm a human. Like just come up with those first before you do that too much.
I know. I love that movie growing up. It's great.
Let's see here. So we've got, and you can just stare at the camera and blink. This one's a little detailed. If something got printed and turned out wrong, it had a flaw that was detected that was beyond the size, like you mentioned, how do you fix it? Are you melting it down? Are you just cutting that off and reprinting?
Yep, it's basically cut off and reprint.
Okay.
That's the basic approach. Yeah, but again, one of those things sounded really easy, and to actually get it to work, very hard. But it works very reliably now. Even the first flight rocket has probably a decent number of cutbacks and reprints. And but what is interesting is, even on the flight vehicle, from where we started printing it at the base of the second stage all the way through the first stage, which we printed second, the quality is significantly better. You can actually see the quality improve across the length of it as we printed and just kept getting smarter and things getting more fine-tuned.
That's cool. It's not just iterations between vehicles, like vehicle 1, vehicle 2, vehicle 3. It's like as you go up this vehicle, you dial it in, you use what you learned on the first layers for the 50th layers and the 100th layers and that sort of stuff. Yeah. That's really cool.
Exactly.
You talk about rapid iteration, that's rapid iteration. Like
fundamentally, it should be more reliable over time, because data and software and computers are going to be more reliable, and automation is just fundamentally more reliable. We have an amazing technician team, by the way, that tell them they're all still going to be working here. Like we still have a lot of stuff to do and things to build up. So it's really more just about seeing the future happen faster.
Excellent. I'm trying to get as many questions as I can. I know here at the end, it's sort of like the speed run round, the lightning round for questions. We already talked about the autogenous. I said it right? Autogenous?
Yep. Yeah.
You're just supposed to play his soundbite. All right, autogenous, and it is autogenous for Terran 1, correct?
Yeah.
Let's see here. We talked about 3D printing the launch mounts. I'm literally going through. There's so many questions.
Yeah. What about Mueller and the Mars mission? Talk to that.
There you go.
About that partnership, because it's not just Terran R going to Mars by itself right now. You're partnering with Impulse Space. So how did that partnership come about, and what's the details there?
Yeah, sure. So the kind of founding story of that mission. So we've been working with Tom Mueller for about a year. I think Impulse is about a year old. So it's right when he officially started Impulse. That we approached him on it. And it was actually a guy, Zach Dunn, on our team, who was one of the early SpaceX employees and ended up leading all of production and launch for the whole company. He was the SVP of engineering over at SpaceX. And I think it was initially his idea. He thought for our first Terran R mission, what if we just work with a student group and have them, like nights and weekends, build a solid rocket that we just YOLO shoot to Mars to see if we could even get close enough to like take a photo or something.
Yep.
I think pretty quickly me and him both talked and laughed about it, because we thought, well, if we're going to even get close to Mars, we need a real engineering team to partner with and work on. And then Tom was working on an in-space transportation company, which became Impulse at the time, after he left SpaceX. And that seemed like it would be a really good interstage to launch from, Terran R dropping off to trans Mars injection orbit, and then him kind of delivering what then was the lander and aeroshell into the Mars surface. So that's using the same propulsion systems that he's already developing for the transportation system. So there were some synergies there, and we just thought like we actually had the engineering chops to do it. It's like I think partnering with him, because it's not just Tom. There's a bunch of other people on his team that have held extraordinarily senior positions at other private space companies. They've been enormously successful. I actually know quite a few of them, or most of his 40-person team at this point. And they're legends in the field. Like they've been unbelievably successful for their entire careers. And I think they've also all been very used to being bet against, being told landing rockets wasn't possible, landing two stages at the same time with, Falcon Heavy, that wasn't possible. So, I think it's the right mission to do. What I don't care about is it's not a competition with SpaceX. I knew the headlines, no matter what, we're going to say that.
Right. Sure. Our headline was not, for the record.
There you go.
Oh, that's great. That's great. Yeah, because it's genuinely I genuinely am cheering them on and think they're going to be successful. It's like, if I don't know, I haven't talked to Elon about it, but if I did, I'd feel like if I were him, I'd genuinely be frustrated that we're still the only ones trying to do it.
Yeah.
And so I do think, I think that's important. And obviously our architecture is a little more traditional. We're using a lot of the technology NASA, a similar kind of mission to InSight used, just taking that more commercial kind of startup approach to developing hardware and testing and more rapid testing. So it'll certainly be faster and cheaper. And that's really the goal.
Gotcha. I got one more chat question here, and then Thomas, you can't just say that in the back channel, because that's what I was going to ask. It's like, come on, is that your last question, Thomas?
Well, I've got one more.
You've got one other question beyond that. Okay, so what's the level of confidence on the Terran 1 launch date right now? Like, do you have the date firmed up? Are you confident that date's going to happen? How's it looking? We all like rocket launches. We want to see this go.
Yeah, of course. So we're still saying a few weeks. I'm still going to officially have a date after we get through the stage 1 MDC.
Okay.
I will say we've already successfully bootstrapped 9 engines up to full power for 6 seconds. We're planning a 20-second test next, which should get us through most of thermal steady state, as well as testing the autogenous system. Obviously, autogenous already worked on stage 2, but this is stage 1, so we just want to make sure. And then we'd go into the full MDC. So that's the game plan as it stands right now. I think the other part is we're working through the FAA Part 450 launch licensing process, which is brand new. And so that's underway, and we're making progress there. So it should just be a few weeks from now, though.
Gotcha. As long as you don't say 2 weeks. Please never say 2 weeks.
No, not 2 weeks.
Yeah. I'll accept a few weeks. I will not accept 2 weeks.
Yeah, I don't think we'll surprise people that much. But it's not that far away, and it certainly does feel close. And I'm getting very, very pumped.
All right.
Yeah, awesome.
Thomas?
Well, really quick, thank you so much, Tim. Before I ask my final question, I do want to say a big thank you from everyone at the team for all your updates on Twitter with all the test campaign. That's been super fantastic. We're all very much looking forward to the first flight of Terran 1, and thank you so much for coming on the show today.
Yep.
This has been an absolutely amazing conversation, and I know there's going to be more to talk about very, very soon. So my last question for the episode is, when you do finally see your first orbital launch in person, the first flight of Terran 1, where are you going to be watching from?
100%. I'm going to be in the LCC there, supporting the team, making sure I'm close to console, anything that I need to. I know we built out the LCC, so there's kind of a viewing room, and I'm sure I'll have, wife there, and just, it's going to be emotional, by the way. 100% guaranteed I'm probably going to cry, like, no question. Especially because it's my first one. I've waited so long, and I told myself it had to be my company to make it, and just, to get from 2 people in a WeWork saying we were going to 3D print a whole rocket to where we are today is, we've got a lot more to go. That's mostly what I'm focused on a daily basis, is how much more we have to go. But I think it's going to be definitely a moment that heads are in the game, but it's going to be super, super emotional.
Excellent. As long as there's like an easy access door, so for your first orbital launch,
I'm going to run out.
Open that door, and you get actual
I've already
photons from the
plotted-
rocket to your eyes.
Yes, I've already. Oh yeah, don't worry. I've already plotted my path to run outside and
Clear it. There's like a little
Yeah.
aisleway, like clear this space. It's like a fire lane sort of deal.
Yeah, I think
Alright.
it's like, I don't know if it's like 6 feet or something. It's pretty dang short.
pretty short,
For a reason. Yeah.
All right. Well, as always happens, we are out of time here on a Sunday. Tim Ellis, CEO Relativity, thank you so much for not only spending the time with us, but taking time out of your weekend to share this conversation with us, answer so many viewer questions. I know we couldn't get to all of them, y'all, but the questions y'all asked were fantastic. If you think your question wasn't answered, watch it again because he gave us so many answers over the course of the interview. Tim, thank you so much.
Awesome. Thanks, John. Appreciate it. Thanks, Thomas, for having me on.
All
It
right.
was an absolute pleasure. Love talking to you.
Absolutely. And y'all, as always, thanks you to our members for making these sorts of shows possible. We're able to bring y'all things, we're able to bring you shows like this and interviews and questions and launches and all sorts of things because y'all keep showing up and you're watching the shows and you're joining the membership program and that sort of thing. So everybody that's involved, including all of our launch directors and flight engineers, thank y'all so much for the support so we can keep this type of content coming. But for now, that is going to be the end of NSF Live for Sunday, August 7th. Thank y'all so much for hanging out with us. Tim Ellis, one more time, fantastic having you on. Hope to talk to you again in the future, get some more Terran R details, and maybe hear about your experience watching Terran 1 launch in a couple weeks. But for now, we're going to go ahead and shut down the show, and we will see you nerds later. Thanks for watching, y'all.
Awesome. Peace. See ya.
We have liftoff. Propulsion continues to be normal.
RCPT pressure looks good. Following up. Roger, roll, Atlantic.
Water towers fly! Yes!
Tango Delta nominal.
Flight down, feet off. Bring in, feet off.
Yikes. You bet. Concur. We don't need any more of these.